At the end of each chapter of this geometry textbook is a study guide for the chapter geometry test. Like this is study guide for chapter 1 geometry test. There's a homework sheet that looks like this study guide. It's the same number of questions, same type of questions in the same order. And then the chapter 1 test would look like the homework, which looks like the study guide. Because there's a homework for practice for the student that looks like the study guide, that looks like the test, we're going to go over the study guide in its entirety. That will be the instruction review, and then the homework will be used as practice for the student, and then there will be a test that follows that. Okay? And so we will go over this entire study guide. So we began the study of geometry with undefined terms. Those undefined terms were point, line, and plane. The reason that we called those undefined terms is because they really have no size and shape. Remember that a point was a location from algebra, like to the left 3 and up 4, so it represented a certain location in the coordinate plane. And then a line would be like if we took a piece of paper and we actually cut it with a pair of scissors. If you did that, then that line would separate the left half from the right half, but really no paper fell out when you made the cut. So it's really an invisible, imaginary boundary that separates two things, you see. And then we talked about a plane would be like taking a cake and making a slice that cake into two halves, and when you made that slice you could see that it cut across a flat surface, and so that flat surface where the knife went would separate the top half from the bottom, and so it's a flat boundary. Okay, so since points, lines, and planes really take up no space, they contain no matter, then we call them undefined terms. From there, we made some definitions like collinear, coplanar. And we're going to use true or false. And again, we don't use little t's and f's because sometimes people do this silly kind of stuff and make a multiple choice answer. And we don't take multiple choice answers. And so we want you to actually write out the full word true or the full word false, please, if you're taking a test for me. So, points A, I, and G are collinear. Let's see. I've got to get the smartboard working again. It just kind of clicked out on me there. The way I do that is I hit the highlighter and then the pointer button, and then it all works again. So we had point A, I, N, G. There's point A, there's point I, there's point G. Can we draw a line that hits all three? The answer is no. So those are not collinear, so that is a false statement. Okay. Are points B, H, E, and F coplanar? B, H, E, and F. That means is there one plane that will hit them all? B is here, H, E, and F, and the front face of that prism hits all of those. So those are coplanar, so that is a true statement. The next question, are points A, B, D, and G coplanar? Here's A, here's B, here's D, and here's G. And we could draw a diagonal plane that cut through the middle of that rectangle. That thing didn't bend or twist. It's straight all the way down through there. If I drew a nice pretty picture, that is. And so it is true that those do lie in the same plane. They are coplanar. Question number 7, are points B, H, and E collinear? Here's point B, here's point H and here's point E, and it is true that they are all on the same line, so it is true that they are collinear. Any questions on 4 through 7? Question number 8 says, name the intersection of line AB and line HE. And remember, I would have students that would say line AB and they would draw it like this. And then they would say line HE and they would draw it like that. And they would say, well, they don't even hit. But it didn't say segment AB and segment HE. It said line AB, which goes indefinitely through A and B, and line HE, which goes indefinitely through line H and line E. And when we consider that they go infinitely, we can see that the point in which they intersect is point B. Any questions on number 8? The intersection of plane ABCJ and plane ABDE. Now, we do want to know that there's a postulate that exists that says the intersection of two lines is a point. And there is a postulate that exists that says the intersection of two planes is a line. So we should know from our memory work that the intersection of two planes is a line. When we go to the picture, that's not what we're going to see. In the picture, we would see ABCJ as being the left face of the prism. And we would see ABEF as being the front face of the prism. And we would say, well, what they have in common is segment AB. But in theory, plane ABCJ doesn't really stop where that face is. It really goes infinitely forever here, see? And it keeps going there. And this plane that contains the first face goes infinitely forever. So if both of those planes go infinitely forever, then their intersection also goes infinitely forever. And so the intersection of those two planes is this line that contains point A and point B. And so the intersection of the two planes is the line AB, not the segment AB. In the picture, it's a segment, but in theory, it's a line, okay? Sections 10 through 12 are relating to this picture here. It says name 3 segments. A segment is a part of a line that contains 2 points and all the points on the line between those two. We name a segment without errors. So we could say the part of line AB that starts at point A and stops at point B and contains all the points on line AB that lie between point A and point B. So that. Or we could say the part of line AB that contains point B and C and all the lines in between. That would be a segment, BC. Or we could say the part of line AB that contains point A and C and all the points that lie on the line that are between those two. So we would have segment AC. Okay. Name 4 rays. Now, ray A this way would be the part of line AB that starts at point A and goes indefinitely to the right, and you could name that ray going infinitely to the right by using the second letter as B or the second letter as C. So you could call that ray ray AB, or ray AC. If we started at the other end and went to the left, then we could name that ray. Notice even though the ray is facing left, we still named it with an arrow facing right, with the endpoint C first and then any point on the ray. So we could call that ray CB or ray CA. So that got the ray starting from A going to the right and the ray starting from C going to the left. We could have a ray starting at B, and there's two rays that start at B. One goes to the right and one goes to the left. So we have ray BA going to the left and ray BC going to the right. Ray BA and ray BC are called opposite rays, and they form a straight line. So the pair of opposite rays then would be those two rays with the common endpoint that went in opposite directions, which were ray BA and ray BC. Any questions on section 10 through 12? Okay. 13 through 15, it says the midpoint of AG, so we would find AG, which is here. Now, one way to find the midpoint would be to count over, so we're going to go over 1, over 1, over 1, over 1, over 1, over 1, until we find the middle. And we can say, well, it must be at D because it took us the same number of jumps from the right and the left to make it to that point. So it must be the point in the middle. And so the point in the middle is point D. Now we could have done the same thing mathematically. We could have used the coordinates. The coordinate of A is at -4 and the coordinate of G is at 2. So we could have said, well, if it's in the middle, then it's going to be the average of those two, you see. Remember the midpoint formula, which said to find the midpoint of a segment on a coordinate plane, you would take the average of the x's, comma, the average of the y's, x1 plus x2 over 2, y1 plus y over 2 over 2. You find that on page 177 of the Algebra 1 text. But this is just the x-axis portion of that, you see. So we would take the average of the endpoints. When you take -4 plus 2, you get -2 divided by the 2 on bottom, which gives you -1. And so the midpoint must have a coordinate of -1, and the point that has the coordinate of -1 is point D. So that's using the midpoint formula from Algebra 1 to find the coordinate and then the point associated with it, rather than doing so many jumps from this side and that many jumps from the other side until we worked our way to the middle. Now remember, a bisector is a line, segment, ray, or plane. It's an object that divides a segment into two equal segments, and to do that it had to hit its midpoint, right? Okay, so we're talking about CG. Halfway between C and G is point E, so E would be the midpoint of segment CG. So a bisector of segment CG would be an object that hits CG at its midpoint E, and the object that we see that does that is segment FE. So we could say that segment FE bisects segment CG. When it says find BI, it doesn't mean go, ooh, there's B and there's I, so I found them. Remember that this means line BI, and this means segment BI, and this means ray BI, but BI with nothing above it means to find the distance between point B and point I. And to do that, we use what we call the ruler postulate. And the ruler postulate says that you take the absolute value of the difference of the coordinates of the points to find the distance between them. So we would go to this diagram. We would find the coordinate of point B, which is -3, minus from the formula the coordinate of point D, which is -1. We have -3 minus a -1 is a +1. When you add or subtract with different signs, you subtract and take the larger sign. Absolute value represents distance from 0, and the distance that -2 is from 0 is 2. And so we would say that BI, and I obviously grabbed the wrong number, so I guess I'll back up. I said BD instead of BI, and then I really made a lot of mess out of that. BD would have been 2, but it didn't ask for BD, it asked for BI, so let me start over. The distance between point B and point I would be equal to the absolute value of the difference of the coordinates of B and I. Point B is at -3. Point I is at 4. So we have -3 minus 4. They're both negative. When you add or subtract with the same sign, you add and take the common sign. Absolute value represents distance from 0, and -7 is the distance of 7 from 0. And so we would say that the distance between point B and point I is 7 units. Okay? Any questions on that? That's called the ruler postulate. The ruler postulate. Number 16 through 18, name 2 more names for angle A. We can name an angle by a point on one side and then the vertex and the point on the other side. So we could have called that angle BAC. We could have started from a point on this side C to the vertex and then the point on the other side B. Going that way, it would have been called angle CAB. Any questions on number 16? Remember, the formal definition of an angle is a figure formed by 2 rays with a common endpoint. The 2 rays are called the sides. So the sides of this angle, are ray AB and ray AC, and that common endpoint is called the vertex, and so the vertex is point A. An angle is a figure formed by 2 rays with a common endpoint. The 2 rays are called the sides, and the common endpoint is called the vertex. Any questions on number 18? Okay. Next section. The next section is dealing with types of angles. It says acute angle. Remember, an acute angle is between 0 and 90, which does not include 0 and does not include 90. And so one acute angle would be this one. It measures 45. Its name is angle DBC. You cannot call it angle B because there's more than one angle at B. We could have called that one angle DBC or angle CBD. Another acute angle is this other 45-degree angle adjacent to it, and its name is angle EBD, which we could have also called angle DBE. Now we know that if those two are 45, then the sum of 45 and 45 is 90, so that must be 90 right there, which means that that is a right angle, and its name is angle EBC, or we could have called it angle CBE. If that is a right angle, then the one adjacent to it that forms a linear pair with it must be 90 degrees also. And so the other right angle is angle EBA, which could have been called angle ABE. It's kind of nice when it says name one obtuse angle and it gives you two blanks. I'm sure you found that quite interesting. An obtuse angle is going to be more than straight over and straight up, and so that would be like this one right here, which has the name angle ABD. It could have also been called angle DBA, and you can ignore the fact that there's two blanks and it asks for one angle. Maybe that's not in your student edition, I don't know. Name a straight angle. A straight angle is exactly 180 degrees. And you may say, well, how can that be an angle? Well, the definition of an angle is a figure formed by two rays with a common endpoint. Considering B to be the common endpoint and ray BA and ray BC being opposite rays, then that was an angle formed by those two opposite rays, and we name it by a point on one side, vertex in the middle, point on the other side. So we could call that angle ABC. We could have also called it angle CBA. The next thing says name two angle bisectors, and an angle bisector is a ray that divides an angle into two equal adjacent angles. Seeing that those two angles are 45, then ray BD must have bisected this whole big angle, angle EBC. So the angle bisector there was ray BD. Not only do we have two 45-degree angles, we also have two 90-degree angles. This right angle, angle ABE, is adjacent to this right angle, angle EBC. That means that there was a straight angle, angle ABC, that was bisected by this ray right here, and it made two 90-degree angles, two equal adjacent 90-degree angles. And so we can say that ray BE bisects angle ABC. So ray BE was another angle bisector. Any questions on sections 19 to 23? Okay. All right, so now we're getting back into the points that determine a line and all of that. So what does it take to determine a line? Any 2 points. What does it take to determine a plane? 3 non-collinear points. 3 points not all in the same line. What does it take to determine space? 4 non-coplanar points. How many lines can be drawn through 1 point? An infinite number. How many planes can be drawn through 3 non-collinear points? 3 non-collinear points determine a plane. That means one plane can be drawn through 3 non-collinear points. It determines a or one plane. How many planes can be drawn through 3? Collinear. Well, a plane has not yet been determined if it's collinear, so an infinite number of planes. We'll just say infinite planes. We should more proper to say an infinite number of planes can be drawn through 3 collinear points. Any questions on that? And then we want to keep drilling it in your head for the later purposes of finding perimeter area and volume and doing the conversions between inches and square inches and cubic inches to inches to feet and square feet and cubic feet. A rectangle, which represents a plane, has 2 dimensions, and we represent its area with a power of 2. In other words, square inches, square centimeters, square feet. A segment has 1 dimension, which we call length, and we represent that with the power of 1. In other words, we would measure length in inches, or feet, or centimeters, and the exponent is an understood 1 that we really wouldn't put on it. Notice the exponent is the same as the number of dimensions. A prism, which represents space, has 3 dimensions, and its volume is represented by a power of 3. And so we would measure volume in cubic inches, or cubic feet, or cubic centimeters. A point has no length, no width, no height. It has no dimensions. That's why it was an undefined term. Any questions on 30 through 33? Now, on these, if it says draw and label the following, if it gives you a unit of measure, it must be exact on the test or I won't count it right. That means you had to have used a ruler and measured correctly, and you had to have used a compass or protractor and created exactly. You can't just freehand it and guess. If you're taking a test for me, David Ballard, or it will be counted wrong. Now, your teacher may allow different things, but I don't allow that. I expect precision anyway. Line T intersects plane M in point X. Now this you can freehand because it didn't have an exact measure. We represent a plane with a parallelogram. We would name that plane by a capital letter. We want a line to intersect it, and the way we do that is we show it coming down, and we have the point that that line hits. At the point it hits, we're going to dot it as if it went underneath a sheet of paper, like running a pencil through a piece of paper, and then we could see it come out the other side. And now, that got kind of messy, so I want to do a little bit better job there. So we would, begin with the plane. I've got to get my board to work for me here. So we're going to, again, represent the plane with a parallelogram, and we name a plane with a capital letter. We're going to visualize a line coming down, hitting the plane, going underneath it, and coming out the other side. We're going to call that line line T, and the point at which it intersects the plane, point M. Any questions on that? Now on the next one, it says M is the midpoint of QR, and QM is 3/4 inches. Now when it says 3/4 inches, then I want it exactly 3/4 inches. And I'm going to blow this up just a little bit. If this was a ruler and this was at 0 and you had your 1 mark right here, then halfway between that 1 mark is going to be a half, and half of a half is a fourth, and half of a fourth is an eighth, and half of an eighth is a 16th. And you have to know that to be able to measure. And so I would expect that you would lay your ruler on your paper, and you would go from the edge of your ruler, which would be at 0, and make a dot, and then you would find where the 1/2 is, And there would be a mark like this before the half, which would be a fourth. And then you're going to have your 1 whole inch over here. And there's going to be another mark the size of that fourth mark over here. And you could actually look and see that it would take 1, 2, 3, 4 of those things to make the 1 whole inch. And we're talking about 3/4 would go 1, 2, 3 of those. And that would be the QM. Now, that's the little piece. It says M is the midpoint of a bigger piece, QR. That means we need to go another 3/4. So you'd find another one of those fourths, and then another one of those fourths, and then another one of those fourths, which would actually put you at 1.5. And that's where your point R would be. So you would have created segment QR with a midpoint of M, so that QM is 3/4 inches, and I would like you to label that, and MR is also 3/4 inches, okay? Again, we expect you to use your ruler and it to be exact. If it's not, it will be counted wrong if you're taking a test for me. Okay. It says ray XR bisects angle XYZ. So XYZ is the big one, and it says that it's 84 degrees. So what we would do to measure is we would just start off drawing a ray on our paper. And then we would take our protractor, and we would take the bottom of the protractor or the hole in the protractor, and we'd put it right there, and we would lay our protractor on top. And then we would come over here to 84 degrees, wherever that's at on our protractor, and we'd make a little mark. And then we would lay our protractor aside and get a ruler, and we would measure from here to that mark, and that would give us an 84-degree angle. Now, we could figure out what half of 84 was, which is 21 degrees. I'm sorry, which is 42 degrees. I halved it twice, didn't I? And we could actually find the 42-degree mark while we still had our protractor there, and then remove it and get a ruler and measure this and that both, and go ahead and get our angle bisector. So we would have that XR bisects angle. I made a mess out of that, didn't I? I should have said YR, shouldn't I? If the vertex is Y, then my angle bisector has to have an endpoint of Y. Sorry about that. So this would be my Y. So ray YR bisects angle XYZ. You might find a few mistakes in this book, and when you do, I apologize. Okay? Any questions on number 36? Okay? And then we have some word problems at the end. And again, we're going to approach these word problems the way we did on the in the Algebra 1 book when it's big fancy word problems. If it's not, then we'll approach them just from a common sense standpoint, I assume. Steve bought 3 pieces of board. The first was 3.5 inches long. The second was 4 1/3 inches long, and the third was 5 3/4 inches long. How many total inches of board did Steve buy? Now, total means add, so we're going to add up the pieces. So we're going to have 3 1/2 plus 4 1/3 plus 5 3/4. Now, this particular geometry book has lots of fractions and things in it, because real life is full of fractions, and so we need to know how to find common denominators and add and subtract and all of that good stuff. So we're going to find a common denominator between 2, 3, and 4, which would be 12. The common denominator is the least common multiple between 2 and 3 and 4. And the way you find the least common multiple is on page 8 of my Algebra 1 text. And it says that you would do the prime factorization of each of the numbers and write that exponentially as shown. You then would take the largest power of each prime. We have primes of 2 and 3. The largest power of 2 was 2 squared. The largest power of 3 is 3 to the first. You take the largest power of each prime involved and multiply. So we would have 2 to the second times 3 to the first, which is 4 times 3 is 12. And so the common denominator between 2, 3, and 4 would be 12. And now it's time to make equivalent fractions. So we say 1 times what is 12? 2. So 1 times 2 is 2. Wrong. That was weird. I was thinking about something. Sorry. 1 times what is 12? 6. So 1 times 6 is 6. 3 times what is 12? 4. So 1 times 4 is 4. 4 times what is 12? 3. So 3 times 3 is 9. So then you would add them up. 6 of those plus 4 of those is 10 of those plus 9 of those is 19 of those little 12ths. So then you would take the 19 divided by 12. It will go one time. You get 12 with 7 left over. You put the remainder 7 over the divisor 12, and so you have 1 and 7/12 inches. So we're going to take that 7/12. We're going to take the 1 from that whole number, and we're going to carry it over to the whole number section. So we're going to have 3 plus 1 is 4 plus 4 is 8 plus 5 is 13. So we end up with 13 and 7/12 inches, which we know 12 inches is a foot. So we could say 1 foot 12. We could say 1 foot 1 and 7/12 inches. And a foot is a 1 ditto mark. And inches is a 2 ditto mark. And so we could say 1 foot 1 and 7/12 inches like that. The question is total inches. So if we write the answer in the format of the question, then it would have been 13 and 7/12 as inches. Any questions on number 37? Number 38. Jill was making a dress that called for 3.5 yards of material. If she was going to make 3 dresses, how many yards of material does she need to make? So it's 3.5 yards per dress. She's going to make 3 dresses. And I want to show you this because this is important. You probably tapped into this if you were in my geometry class. When we said yards per dress, you probably were thought blah per blah, which we would have said slope in Algebra 1. If we take the yards per dress and we multiply by the number of dresses, then dresses cancels out and we end up with the number of yards. Yards per dress times number of dresses is yards. And we call that dimensional analysis, which is the MX looking portion of y equal mx plus b. That's how it kind of got created. So really, that's kind of what we're doing. Now, just looking at the numbers we have on the board, we're trying to multiply. And what we learned in Algebra 1 on page 5 was that when you multiply the numbers and you multiply the names and you get a new name. And the fancy word for numbers is numerator, and the fancy word for name is denominator. But to multiply, we get it in fraction form, improper fraction form, so we can see the numbers and the names. So to do that, we say we have 3 sets of 2 halves is 6 halves, plus 1 more is 7 halves. Remember that? And then to change a whole number to a fraction, we put it over 1. And so then we multiply the numbers, our numerators, and we get 21. And we multiply the names, our denominators, and we get 2. So we have 21 halves. Yards, we could change that back into a mixed numeral by dividing. That'll go 1 time, you get 2 with 1 left over. If we want a mixed numeral, we would put our remainder 1 over our divisor 2. But don't forget, even though that was our remainder and our divisor, there was a little gap, and so we have to put a 0 as a placeholder, and so it's actually 10 and 1/2 yards. Of material. Any questions on that? Okay. Again, in the Algebra 1 text, if you go to page 5, it's going to teach you to multiply. Page 7, it's going to show you how to multiply mixed numerals. Okay. Number 39. Angle 5 and 6 are a linear pair. Now, what we know about linear pairs is that their sum is 180 degrees. So angle 5 and angle 6 are a linear pair. That tells us that angle 5 plus angle 6 is equal to 180 degrees. And again, what I have my students do from Algebra 1 is to pull things that we can make equations out of onto a word sentence line and then make the equation that results from that. On page 40 of the Algebra 1 text, it tells us what types of things we could make word sentences out of, which could be formula words, or it could be a comparison between two characters. That's the A in step 3 of page 40. And so this compares angle 5 to angle 6. It says angle 5 is 5 times larger than angle 6. We have subject verb, and so we put subject equal. The verb is equal. So angle 5 equal. 5 times means multiply, so 5 times angle 6. And it looks better to show our multiplication with a parenthesis when you've got angles involved. Now, we learned on page 42 of the algebra text that you can't solve with 2 variables. We have to get down to 1. And so we're going to find the place where 1 variable is isolated, take what it's equal to, and put it in its place in the other equation to get us down to 1 variable. And once we're down to 1 variable, then we can solve using the order of operations. So we're going to replace angle 5 with what it's equal to, 5 times angle 6. And so we have that plus angle 6 is equal to 180 degrees. And so now we're down to 1 variable, and so we solve using the order of operations. And the order of operations horseshoe is on page 33 of the Algebra 1 text. And here's how we said that. We said, see if there's anything that you can do to simplify. In the order, please excuse my adherent Sally, looking for distributive property and combining like terms, and we find like terms. So 5 of those angle 6's plus 1 more of those angle 6's would make 6 of those angle 6's is equal to 180 degrees. There's nothing else we can do to simplify. The variable is not on both sides, so it's time to undo. We would undo multiplication by division, and we would get that angle 6 is equal to 30 degrees. Now that we have angle 6, we can plug it in place of angle 6 over here and get angle 5. So we have that angle 5 is equal to 5 times angle 6, which we found to be 30 degrees. And so angle 5 is equal to 150 degrees. So angle 5 is 150 degrees. Angle 6 is 30 degrees. Any questions on number 39? Okay. Number 40. Adjacent angles 1 and 2 form angle EFG. Now that's getting a little complicated here, so we're going to draw a picture. Angle EFG was the big angle formed. It was formed by angles 1 and 2, two smaller angles. Remember, if you get stuck in the mud, you put it in four-wheel drive. If you get stuck in geometry, you draw a picture. If angle 1 is 2x and angle 2 is 2x plus 16, that shows us that angle 2 is a little bit bigger. So somewhere in here we've got two angles. Angle 1 is a little smaller than angle 2, and angle 1 is represented by 2x degrees, and angle 2 is represented by 2x plus 16 degrees. Now, by angle addition, we know that the sum of angle 1 and 2 is equal to angle EFG. So we can say that angle 1, which is 2x degrees, plus angle 2, which is 2x plus 16 degrees, is equal to the whole big angle, angle EFG, which is 96 degrees. And so we have a mathematical equation which involves only one variable x, which means we can solve using the order of operations horseshoe. So we say, is there anything that we can do to simplify? In the order, please excuse my dear Aunt Sally, looking for distributive property and combining like terms, and we see that we can combine like terms, and so we get 4x plus 16 is equal to 96. There's nothing else we can do to simplify. The variable x is not on both sides, so it's time to undo. Remember that when you undo, you reverse the order of operations. Sally, Aunt dear, my excuse please, by using inverse properties. So we would undo addition before we would undo multiplication, and we undo using the inverse. The inverse of addition is subtraction. So we get 4x is equal to 80. Now we're going to undo multiplication by its inverse, and we get x is equal to 20. Now the question is, what's angle 1 and 2? So we would have to take the 20 and plug it in. So angle 1 would be 2 times 20 degrees, which is 40 degrees. And angle 2 would be 2 times 20 plus 16, which would be 40 plus 16, which is 56 degrees. So angle 1 is 40 degrees, and angle 2 is 56 degrees. Any questions on that? So that concludes angle 1. It is very important as a geometry student that you memorize with understanding every definition, postulate, and theorem in the textbook. If you don't start doing that at the beginning, pretty soon you'll be halfway through the year and you won't be able to function in geometry because of your lack of knowledge. Please be sure and do the memory work that you need to do for this course as you go through this course, so that it doesn't build up on you and you get to the point where it's a little bit discouraging to try to catch up. All right, so that is the end of chapter 1. Good luck on the chapter 1 homework and test, and we will begin recording.